Hello friends, welcome to our YouTube channel Railway Engineering by Subbarao. Today our topic is Railway Curves Part 17. In Railway Curves Part 17, Twist and Transition Curves. This Part 17 video has been explained about twist parameter, why twist introduced on transition curves, what are the advantages by introducing a twist on transition curves, what repercussions without a twist on transition curves. Twist is one of the track parameter calculated by using cross level values at two locations separated by a specific distance, that is base. It is also defined as the rate of change of cross levels in mm per meter over a given base. Next, design twist. In the transition portion of curve, design twist is there for introducing or removing the superelevation in the circular portion of curve. The above factors aid into the safety margin available on straight track against the safety. Any further defects in track parameters, vehicle defects and engine manship might easily result in unsafe conditions of the vehicles. The gradual change of curvature is accompanied by gradual change in superelevation in a transition curve. The change in superelevation induces twist in the track. Again I am repeating, the change in superelevation induces twist in the track. The twist is defined as the algebraic difference of the cross levels at 2 points in track divided by the distance between 2 points. So, twist is one of the most important factors affecting safety of the vehicles. On transition curve, therefore, the twist introduced has to be kept well within limits. Next, the cant gradient shall be limited to 1 in 720 or 1.4 mm per meter on Indian railways. However, in exceptional circumstances, the cant gradient may be relaxed to 1 in 360 or 2.8 mm per meter. Further, it is desirable to maintain the track geometry for a comfortable ride at sectional speed. The limits of twist as per measurement in floating condition for guidance of the engineering officials regarding condition of the track from passenger comfort perspective shall be calculated on a base of 3 meter length. Number 1. On straight and curved track other than transition 3.5 mm per meter. Next, number 2. On transition curves 2.1 mm per meter for higher speeds. Advantages by introducing twist on transition curves. When a train moves over the curved track, contributed forces are centrifugal force and centripetal forces due to continuous changing in direction. So, therefore, certainly there are large lateral forces on the track as well as vehicle, and it leads to discomfort to the passengers. Then next, to manage the effect of large lateral forces, the outer rail needs to rise with respect to inner rail, that is providing superelevation, that means introducing twist. Therefore, advantages by introducing twist on transition curves are: number 1, to ensure a better distribution of load on both rails. Number 2, to reduce the wear and tear of the rails as well as rolling stock. Number 3, to neutralize the Effect of lateral forces. Number 4. To improve comfort to passengers. Then next, repercussions without twist and transition curves. Number 1. Providing zero superelevation, that is without cant. Number 2. Due to zero superelevation, wheel flange always trying to climb over outer rail and causes derailment. Next, number 3. To avoid such situation, speed to be reduced, that is speed to be calculated with zero cant or zero superelevation. Dear friends, welcome back. Twist and transition curves. First of all, what is a twist? Twist is a rate of change of cross level with a fixed base. How twist is defined? You take any four legs table, you remove a half inch for one leg. Then what will happen? Particularly, three legs are exactly touching the floor, whereas fourth one is not touching. If any load comes on this fourth one side, this table will be tilted like this. So the tilting is called a twist. Similarly, here also, this is left side rail, this is right side rail, this is direction of movement, this is front wheel set, this is rear wheel set. While moving, here it is right side, one place low. Then automatically, so entire load come on this wheel. Rear wheel one side down means this effect exactly its opposite wheel. It is offloaded, so that is lifted. When wheel is lifted, automatically this is prone to derail. In a straight track, it is happening like this means, what about transition portion? Why? Because in transition portion or circular portion, whatever may be the, while moving this wheel, due to centrifugal force, it is trying to mount the outside of the rail. Due to this wheel flange thrust on outer rail gauge face, more wear and tear takes place in outer rail of the curve. So that's why we are applying the grease on outer rail gauge face to reduce the wear and tear. Of course, that will be discussed in next upcoming videos. The wheel movement is always on straight, but due to curved track and it is guided by the wheel flange, so it is turning like this. So dear friends, if such a situation in case of transition curves, what will happen with safety? So that is the purpose. Our genius engineers practically experienced and researched and they are fixed the limits for twist for non-transition curves 3.5 mm per meter. For transition curves, desirable 1.4 mm per meter. Its cat gradient is 1 in 720. In exceptional circumstances, 2.8 mm per meter is permitted and its cat gradient is 1 in 360. So dear friends, keep it in mind, that is while maintaining the tracks in your jurisdiction, don't take any chance. If you found such a situation, attend immediately. How to calculate the twist, either on straight track or transition portion. While measuring the gauge and cross level on floating condition, some levels fall on left side, some levels fall on right side. That is either left side or right side. Again, it is turn left, again turn right like this. For which there are three cases. Case 1, cross levels are in one side. This is left side rail, this is right side rail. Every fifth sleeper levels are measured. So that is 5 into 0.63 meter. left side 16 mm left lobe. Next, fifth slipper 20 mm left lobe. So that is the base of 3 meter. Twist is equal to algebraic difference of cross levels divided by the length of the base. Algebraic difference of cross levels. So that is 20 mm minus 16 mm by base 3 meter. That is equal to 4 by 3 after simplification 1.33 mm per meter is less than 3.5 mm per meter. So this is permitted value. Next, case 2, cross levels are in both sides diagonally opposite. This is left side rail, this is right side rail. So in first slipper 4 mm right lobe. After fifth slipper 5 mm left lobe. Here algebraic difference is 0 plus 4 minus of minus 0 plus 5, that is 5 plus 4 by 3 meter base, that is equal to 9 mm by 3, that is 3 mm per meter. This is also less than 3.5 mm per meter. Both the values are non-transition curve. So this may be applicable for straight portion as well as circular portion. What about transition curve? That is case 3. Cross level in transition curve between straight and circular portion. In between, transition curve is there. Gradually increase the radius as well as superelevation. We are introducing the twist on transition portion. The change of superelevation induced the twist in the track. Length of transition 40 meter, superelevation 60 meter, then station to station distance 10 meter. So automatically station to station variation of superelevation 15 mm. So that means this 60 mm to be distributed within distance of 40 meters. This is outer rail of the curve. This is inner rail of the curve. Stations should be marked at the web of outer rail, whereas Versine and superelevation should be marked web of inner rail. Here it is station number 0, TPTC 1. Next station number 1, station number 2, station number 3, station number 4, station number 5, so on. Station number 4, TPCC1. So this part is a straight portion from 0 to station number 4. This is a transition portion. From station number 4 onwards, it is circular. Again, for TPCC2, then TPCC1, then straight portion. So here, station 0, superelevation 0, station 1, superelevation 15, station number 2, superelevation 30, station number 3, 45, station number 4, 60, so on 60. Then, what is the twist here? I have selected station number 3 and 4. Twist is equal to 60 mm minus 45 mm by how much station distance? Station 10 meter interval. Base is 10 meter. 15 mm by 10 meter. Particular transition portion, twist is equal to 1.5 mm per meter. Here what is the condition? The desirable twist in transition curve is 1.4 mm per meter. In exceptional circumstances, 2.8 mm per meter is permitted. Next comes to cant gradient is equal to cant divided by length of transition. Cant means here 60 mm. 60 mm by length of transition 40 meter. 40 meter means 40,000 mm. After simplification 0.0015, that is 1 in 666.67. Of course, for 2.8 mm per meter twist, cant gradient is 1 in 360. Whereas 1 in 666.67, it is flatter than 1 in 360. Hence it is permitted. So this is one aspect. Then we will go to other aspect. Any unknown person, they don't know about the twist. While observing these values, here it is 16 mm, here it is 20 mm, so more values. So generally they may think that here it is more dangerous, but always keep it in mind. If cross levels fall on one side of the rail, for algebraic difference of cross level is difference of cross level only, that is 20 minus 16, only 4 mm with the fixed base 3 meter. Twist is equal to 1.33 mm per meter. It is very small comparatively this 3.5 mm per meter. Then comes to case 2. Cross levels are both sides diagonally opposite. For algebraic difference of cross level is adding of cross level only. While moving the vehicle, it is continuously coming 0, 0, 0. Suddenly it is 4 mm low. Then after fifth slipper, again it is low. So this vehicle is moving such a faster speed from this orientation to again it is turned this orientation. So here it is, twist is more, 4 plus 5, 9 mm per 3 meters. 9 mm per 3 meters means 3 mm per meter. Whenever cross levels are diagonally opposite, it is very, very dangerous. You observe the both here. Unknown person, definitely they will think that here it is twist is more. But whereas same person, while seeing these values, here it is also very less, so twist is less. Comparatively, this is 1.33, this is 3. Almost all 3 times more. Okay friends, thank you for watching this video. If you are interested, kindly like, subscribe, share your friends group and ask them to subscribe such more technical and practical videos. Thank you very much.